Good morning, students. Today we are going to discuss the second part of exercise 9.2, that is question number 4, 5, and 6. In question number 4, we have in figure 9.6, P is a point in the interior of the parallelogram ABCD. We have to show that area of the triangle APB plus area of the triangle PCD is equals to half of ABCD, and area of the triangle APD plus area of the triangle PBC is equals to area of the triangle APB plus area of the triangle PCD. So there are two parts for this question. The first part, the figure is given, and in that figure EF is a line which passes through P and parallel to AB and CD. So in this parallelogram ABCD, AB is parallel to EF by our construction, and ABCD is parallelogram implies AD is parallel to BC. So together from this we can get that AE is parallel to BF. That is, a part of a parallel line is parallel to each other. So from equation 1 and equation 2 we obtain that AB is parallel to EF and AE is parallel to BF. Therefore we can say that the quadrilateral ABEF, that is the top quadrilateral ABEF is a parallelogram, and in this parallelogram we have a triangle APB. So we can say that whenever there is a triangle and a parallelogram having a same base AB in this case and lie between the same parallel line, AB is parallel to EF, we can say the area of the triangle is half of the area of the parallelogram. So area of APB is equals to half of ABFE. Similarly, using this same thing, we can say that as ABFE is a parallelogram, similarly EFCD is also a parallelogram, and in this parallelogram we have a triangle CPD. So using the same arguments that we have used before, so we can say that the area of PCD is equals to half of area of EFCD. So from this two equation 1 and equation 2, we can say that we can add them up. After adding, we will get area of APB plus area of PCD is equals to half of area of both the small parallelogram, that is ABFE and EFCD. So ABFE and EFCD together will give us ABCD, the full parallelogram. So the first proof is done. Next, move on to the second proving, that is, now we will draw a line which is parallel to AD and passes through P. So MN is a line which is parallel to AD and also parallel to BC. Now in this parallelogram ABCD, by construction we are making MN is parallel to AD, and since ABCD is a parallelogram, we have AB is parallel to DC, so we can say that AM is parallel to DM. So now we have the figure like this, where A, M, N and D is a parallelogram, and in this parallelogram we have a triangle APD. So when a parallelogram and a triangle having a same base AD in this case and lie between the same parallel lines AD parallel to MN, we can say that the area of the triangle is half of its area of the parallelogram. Using the same argument, when we add up the other part of the diagram, that is when we add up BC to the diagram, we have another parallelogram, that is MBCN. This is a parallelogram, and in this parallelogram we have a triangle BPC. So BPC is a triangle having a same base BC with the parallelogram and lie between the same parallels, that is BC parallel to Mn. So we will get area of PBC is equals to half of area of MNCB. When we add this up, we will get like before, that half of area of APD plus area of PBC is equals to half of area of AMND and area of MBCN. Together we will get half of ABC. Now this equation 10 and previous equation of equation 5, together the right hand side is equals to half of ABC, this part. So we can write both the left hand part together, left hand part in this equation like this: the area of the triangle APD plus area of the triangle BPC is equals to area of the triangle APB and area of the triangle PCD. So this was our second proof for the first question. Now we will move on to the question number 5. In question number 5, there are two parallelograms ABRS and PQRS. Here X is a point that lies on BR. We have to show that the area of the parallelograms are equal and area of the triangle is equals to area of the triangle AXS is equals to half of area of PQRS. So it is a very easy sum. We have a parallelogram like this. This is PQRS and we have ABRS as well. Here is B, and in this line there is a point X. So first of all, both the parallelogram lie on a same base SR, and also between the same parallel lines SR parallel to PB. So we can say the area of the parallelograms are equal by theorem 9.1. Again, if we consider the triangle AXS and the parallelogram PBRS, so from this two we can see they lie on the same base, that is AS, and the same base is AS, that is not written, and same parallel line, that is SR, is parallel to BR. We can say area of AXS is equals to half of area of ABRS. From equation 1 we can substitute ABRS with PQRS. So we will get area of AXS is equals to half of PQRS. So it is proved. Now question number 6. In this question number we have a farmer having a field in form of a parallelogram PQRS. She took a point A on RS and joined A to the point P and Q. In how many parts the field is divided? What are the shape of these parts? The farmer wants to sow wheat and pulses in equal portion to the fields separately. How should she do it? So here is the diagram where PQRS is the parallelogram that the farmer has, and A is a point on RS. So the point A divides the field in three parts and they are all in triangular shape. Now this field can be written as area of PSA plus area of PAQ plus area of QRA is equals to area of the parallelogram. Now the triangle PQA and the parallelogram PQRS lie on the same base PQ and between the same parallel lines PQ parallel to RS. So the base is PQ and the parallel lines are PQ parallel to RS or SR. So we can say the triangle is the area of the triangle is half of the area of the parallelogram. Now from equation 1, if we substitute PAQ with half of PQRS, so the rest to triangle area should be equal to the area of half of area of PQRS. So the farmer must sow one part, suppose PQRS, with pulses and other two parts with wheat, or vice versa. That means here in PAQ the farmer must sow wheat, and in PSA and QRA the farmer must sow pulse. If not, then the pulse and wheat can interchange its places. That means PQA, in the area PQA, the farmer can sow pulses, and in this two triangular area PSA and QRA, the farmer must sow wheat. So this is how we can do such word problems. And today we discuss the last three sums of this exercise 9.2. I hope this tutorial is helpful to you. Thank you.